We have this equation x squared plus y squared equals 122y. So first, let's find dy by dx by doing implicit differentiation. So I'm going to differentiate both sides of this equation by implicit differentiation. So first I differentiate x squared with respect to x, so which is 2x plus differentiation of y squared is when we apply the power rule we get y, and then we apply the chain rule to differentiate y, which gives dy by dx, and this equals differentiation of 122y. 122 is a constant, and differentiation of y with respect to x is dy by dx. Now we have to collect the dy by dx terms. So I'm going to subtract this term to both sides. So we will have 2x plus 2y dy by dx minus 122 times of dy by dx, and this equals 0, because when you subtract 122 dy by dx from both sides, the right side will be 0. Now let's factor the dy by dx from these two terms. So we will have 2x plus when we factor dy by dx, we will have first term will be left with 2y, and the second term will be left with 122. So we have negative 122, and this equals 0. And since we want to have only dy by dx on this side, we can transpose this term to the right side, or in fact we can subtract this 2x from both sides. So I'm going to write down this as dy by dx. This time I will put this factor in front, which looks a more familiar way of writing. So this equals negative 2x. Now let's simplify this. Uh, when you We can factor 2 from these two terms. So I'm factoring 2. When I do that, I get 2 times of y minus 61, because 122 divides 2 as 61 times. So this is y minus 61 times of dy by dx, and this equals negative 2x. Now I divide both sides by 2, so that these two as well as these two will get cancelled. So we will have only y minus 61 times of dy by dx equals negative x. Now to solve for dy by dx, we have to divide both sides by y minus 61. So we will get negative x divided by y minus 61. This is dy by dx. But since we want to find out the constants a, b, and c, we are already given this form, that is dy by dx equals ax divided by b minus cy. So let me write down this. That is, we are given the dy by dx in this form. Dy by dx equals ax divided by b minus cy. Now we have to compare this dy by dx with the dy by dx which we got. Uh, it looks like the numerator terms matches. That is, we have x term in the numerator, and here also we have x term in the numerator. However, when you look at the denominator, we have b minus cy. That is the negative cy we have here, but we should have y as negative term. So for that, I'm going to rewrite this dy by dx form by dividing both the numerator and denominator by negative, or else we can uh, transpose this negative to these two terms. So this is ideally equivalent to negative 1 times of x divided by y minus 61. So when you do the algebra, we can transpose this negative to these two terms. That is, we can put this as x divided by negative of y minus 61. And this means we can distribute this negative. This is nothing but negative 1 to these two terms inside the brackets. So therefore, this will become x over when you multiply with negative 1. we have to flip these two terms in their signs. So we have y minus 61. When we flip the signs, we will have positive 61 and negative y. So we can write down this dy by dx as x over 61 minus y. Now, if we compare this dy by dx with the dy by dx given, we have exactly written in the same form. And that means we can easily identify the a, b, and c. So a is a coefficient of x. So I can mark this as a. That is, we have a as 1 here, and then b is the constant term. So this is b. Then negative of y. So we also have negative of cy, and this means we can assume that we have 1 over here. So therefore, we see that c equals 1. So we have determined the value of a as 1. We can put a equal to 1 here, and we have determined b equals 61. So I put 61 for b, and we determine c equals 1. So it is a positive 1. So these are the values of a, b, and c. We will now determine the equation of the line, which is a tangent to the graph of the equation. To find the equation of the line, we need a point. We are already given a point, that is 11, comma 1. And we also need the slope of the line, that is we need m. Remember that dy by dx gives the slope of this line. However, we have to determine the slope of the line at the point 11, comma 1. So basically, we have to find dy by dx at the point 11, comma 1. So let's evaluate this. So we plug in x equal to 11 and y equal to 1 into this dy by dx. So when we do that, we get x is replaced as 11 and y is replaced as 1. So it becomes 61 minus 1, and this gives 11 over 60. So this is the slope of the line at the given point. So we can consider this equals m. Now I'm going to use the point slope form of the equation of line to determine the equation of the line. The point slope form is y minus y1 equals m times of x minus x1. Now we know that x1 is 11 and y1 is 1. And also we know that slope m equals 11 by 60. So let's plug in all this information. That is, we will have y minus y1 is 1. And this equals m is 11 over 60 times of x minus x1 is 11. So let's simplify this. First, I'm going to multiply both sides by 60 so that I can remove this denominator from this right side. So this becomes 60 times of y minus 1, and this equals 11 times of x minus 11. Now let's distribute both these numbers. We will distribute the 60 as well as we will distribute the 11. So when you distribute the 60, we get 60y minus 60, and this equals 11 times x is 11x, minus 11 times 11 is 121. So let me subtract this 60y, or I just transpose to the right side. So therefore this becomes 11x minus 60y, and I also transpose this negative 121 to the right side and when to the left side, and when I do that, it becomes positive 121. So we will have 121 minus 60, and this equals 11x minus 60y. You can just remove this. So 121 minus 60 gives 61, and this equals 11x minus 60y. Or else we can write down in the form as like this. That is, we will have the variables x and y on the left side. So this becomes 11x minus 60y equals 61. So this is the equation of the line which is tangent to the graph of the equation.